Let's study in detail one constraint that you will use for the Enigma problem, which is the modulo constraint. The modulo constraint is y modulo v is equal to x. So let's take the value v equal to 4, and the domain of x is 0, 1, 3, and the domain for y is 2, 3, 5, 6, 7, 10. And let's see together what are the values that we are supposed to remove according to this modulo constraint that we have here. So what you can already observe is that the value 2 is not there. There is no value 2. So the result of the modulo can never be 2. So it prevents you to have this value inside the domain of y, okay? Because 2 modulo 4 is equal to 2. And for the same reason, we can not have this one, because 10 modulo 4 is also equal to 2, and the value 2 is not in the domain of x. So we can remove it. Okay? And for the same reason, we can also remove this one. Okay. So do we see any multiple of 4 in the domain of y? No, the value 0 is not there. 0, 4, 8 is not there. And so for this reason, we can also remove this one. Okay. 5 modulo 4 is equal to 1, 3 modulo 4 is equal to 3, and 7 modulo 4 is equal to 3. So for the rest, we cannot remove them. Okay, so that's all we can do in terms of pruning for the modulo in this specific situation. And what we need to do is to design an algorithm that is able to cross the values exactly just like we did, but inside the implementation. So if I want to implement the modulo constraint, I will extend the abstract constraint class. Of course, this is my constructor. I need the variable, so it's x modulo x is equal to y modulo this value mod that I call mod, okay, but which is equal to v here. And I need to implement this. So what we need to do is post the constraint, and for the post, we need to hook up the event that we are interested to be notified whenever something changes. So what we can already say is that we want to hook up the changes on x. So we can say x propagate on domain change this. Okay, so of course we want to be notified when x changes, but we also want to be notified when the domain of y changes. Okay. And then we need to implement the propagate. Okay, we need to implement the propagate. And so what we need to do for the propagate is that we will need to iterate, we will need to iterate over the domains of the values in x, and also over the domains of the value in y. Okay, so how do we do that? We have several possibilities to iterate over the domain, but the most efficient one is to use the fill array functionality. So we have this method, okay, fill array, that will store all the values inside the domain inside this array. Okay, and so we need to create an array first that I will put here for efficiency reason. Okay, it's an array that will always be used to contain the domains of y. I will call it dom of y. And dom of x. Okay, and this one will be initialized, for instance, in the post. So dom of x is an array of the size of x. And so if I do y.fillArray and I give it dom of y, after that, all the values inside the domain of y will be stored inside this array as a prefix of this array. And I can also retrieve the size, which is the current number of values that has been filled in inside the prefix this prefix array, like this. And then I use a for loop. Let's do like this. Sorry, this was the size of y. Okay. And the value is equal is here. Okay. So what you can already see is that this is the most efficient way, of iterating over the domain of the variable. We use a fill array that will fill in the prefix of this array that should be large enough, okay? And this will tell me the size of the prefix, and all the values, I can collect them by using the for loop from 0 to the size of the prefix, and I can retrieve them, okay? The advantage of this is that you only have to create the array once, and then you will reuse it whenever you need it. And so it prevents you to create objects that will be garbage collected all the time. I create the instance just once. And so fill array is a very efficient way to implement over the domain of the variables inside minicp. Okay, so once I have this value, I can check if x contains the value val modulo dom. Mod. Okay. Because if x contains the value there, it means that the value is supported. The value val modulo mod is supported. And otherwise, if it's not the case, I can safely remove this value from the domain of y. Okay, like this. And so here, what I could do is create a set. Okay, it's really a Java set. And so if this value is supported, I can add it. I will call that supported x to say that it's really the value supported in the domain of x. Okay, like this. Then I need to prune the domain of x. So this was the pruning of y. But now I need to prune the domain of x. And so what I will do is that I will iterate over all the values in the domain of x, and if it does not belong to the supported set that I have stored here, then I can remove it. So I will use exactly the same strategy to iterate efficiently over the domain of x. I will use my fill array method. The size of x is this one. I do x.fillArray inside this temporary array that we have created here. Okay. I use my for loop until the size of x. And if this value does not belong to the supported set, then I need to remove it. Okay. So I can x.remove the value on x of I. Like this. Okay, so this is all we need to do. Once you have your implementation and you think that it's working, it's always a good idea to unit test it. And so I have already implemented some unit tests here, and the test suite is here. Okay, so I can execute the unit test. And this is a kind of test that you can implement yourself. You create the solver, you create some variables. Then you post your constraint. So this is an instance of the object that I just have created. You can do some assertion to verify some properties. You do some domain modification. You remove some values. And so in this case, you see that if I remove the modulo is 2, so if I remove the value 0, it means that all the even values should have disappeared. And so I will iterate over all the even values, and all the even values should not belong to the domain. And this is exactly what I'm asserting here in this unit test. Okay, and this is another one. So anyway, you can implement your test, and then you run it, and you can check that it's working or not. And you see that it's not working, so it means that I have a bug somewhere. Okay. So what the bug tells me here is that the maximum here of x should be 1. Okay. It's quite logical because I have 2, the modulo 2, so the maximum of x cannot be larger than 1. Okay. So it seems that like there is a problem there. So I come back to my constraint. And it's true that in the post method, I should have updated the maximum and the minimum of x. I can remove all the values above the value v. Mod. And remove also below all the values in case they are negative values below 0. So I still have some bugs. And here also I should not forget to propagate at the end once you have posted the constraint. I know it works. Okay, so you see I forgot to propagate initially the constraint. It works, but we can do better. Okay, we can do better than this, because here this set will be executed, will be created every time the propagate is called. And in a typical problem here, the number of times that this propagate method will be executed is maybe millions of times. So a lot of time you will create object, garbage collect them, create garbage collect. So this might be quite inefficient. So one trick that I like to use is the magical trick to create sets. And so I will use the supported X array trick using magic. You will understand quickly what I mean by this. And I will create it here. So supported X here. And I will initialize it here. So I create an array of values of size x.size like this. And I will also have here a magic number. And every time propagate is called, I will call it magic. Every time propagate is called, I will do magic plus plus. To say that all the values that don't have the value magic at the corresponding index are not considered part of this set. Okay, so it's a very convenient way to implement a set that you can erase and clear in just constant time like this. You just increment magic and everything is considered as out of it. And so to add something to the set here, you just need to do this. And you say that at this specific index in the set, you have the magic number. Okay, so it's like a boolean if you want to say that the boolean there is true. Okay, and the check simply consists to say that it's not there. You simply need to do if the supported X at this index is different from the magic number. Sorry. like this, and this is exactly equivalent. So if the magic number is not the same, it means that you didn't add this value to the supported set, okay? And in that case, you can remove it. And so to erase all the values, you just augment the magic number by 1, and this will remove all the values at once. And so this should still work, of course, okay? So it's exactly the same behavior as before, exactly the same algorithm, except that here I don't initialize any object, okay? And this is a little bit more efficient because the garbage collector of Java doesn't need to be called always when you will execute the propagate method. So it's always a good idea to avoid object creation inside the propagate method and pre-initialize them outside the propagate in the post, for instance, and then just update this array data structure afterward, exactly as I did here.